Hey, it's Mr. Shrum, and we went over energy flow through the tutorial on energy flow last time. Now we're going to take a look at the mastery test questions and see if I can offer you any tips or hints about how to answer these questions. But there's not a lot of math going on in this lesson, which is maybe good for you that are not as mathematically inclined. But this is going to be about changing energy into other forms. And how do you know which form it changes into for the specific event? So here it's laundry day at Dan's house. So I guess he's got to iron a lot of his clothes, and a lot of my clothes need ironing. But hey, Dan's a classy man, so he plugs in his electric iron. What transformation of energy takes place inside the iron? Well, if you've ever used an iron or seen your parents use an iron, you plug it in to the wall socket. So that's a clue that it needs electrical energy. And think about what an iron does, right? You're not supposed to touch an iron, at least the bottom side of the iron, because it's hot. When it uses heat, steam, to mold the clothes into the shape you want and get all the wrinkles out. So that will be thermal energy. Which sentences in the passage directly involve the geosphere? Now, do you remember the geosphere? Dealt with minerals and rocks and the Earth's surface, all right? Maury digs a hole in the ground with a shovel and plants a sunflower seed. In time, the sunflower draws water and nutrients from the soil and releases water vapor into the air through its leaves. Energy from the sun is stored by the sunflower. The air also brings rainwater to the soil. Maury eats seeds from the sunflower and gains energy from them. His body uses the energy from the seeds. So really these 1, 2, 3. So he digs a hole in the ground with a shovel. That's the geosphere. He's digging into the ground, the crust of the earth. The sunflower draws water and nutrients from the soil. The soil is part of the earth, the geosphere. Makes sense. The air also brings rainwater to the soil. So anytime you think of soil, ground, think of geosphere. Pro tip. Click it unanswered first. There we go. Potential energy is involved in each of these events. Match each event with its source of potential energy. So the first one, gravitational potential energy, which seems like gravity is pulling something downward. A trampoline expands and contracts from the weight of children. Not quite. A chemical substance reacts with water to give off heat. Also, not what we're looking for. A skydiver jumps from a plane and free falls toward the ground. Yeah, he's starting off from a high point, and gravity sends him shooting down, barreling to the ground. And hopefully he pulls the chute before he splats. That's the name of the game. Elastic potential energy. If you've ever been able to jump on a trampoline, does it seem like it's elastic? I think that's a decent word. Yeah, because you're jumping up and down. The trampoline stretches, but then it maintains its natural shape. So it sends you jumping upward. So you're jumping down, it's elastic, so it'll fling you back up to maintain its shape. That makes sense. Chemical potential energy, well, it says chemical substance. Kind of cheating, kind of easy, but that's the case. Number 4, more tile dragging. Each sentence describes an interaction between two of Earth's spheres. Match each sentence with the spheres that are interacting. Grady swims in the ocean. Well, Grady hopefully is alive. So that would be the biosphere. And the ocean is water. So that's hydrosphere. Lena takes a deep breath. Lena, also alive. Breath, air, atmosphere. There you go. Water vapor condenses on a glass. Gusty winds weather sandstone in the desert. So that one's easier for me. Wind, atmosphere, sandstone, geosphere. Leaving water vapor, hydrosphere, glass, geosphere. Glass may not immediately come off as a part of the geosphere, but it is melted down and then cooled from minerals and substances. So there you go. Excellent. Number 5, more dragging and labeling. Now we're looking at a circuit. Raul creates a circuit using a battery, a light bulb, and some wires. Label the forms of energy on the diagram. So we have, okay, I was confused about where the boxes were for a second, but the light is giving off, well, the light bulb is giving off light. Light is electromagnetic radiation. That is known as radiant energy. A battery is filled with chemical substances. And the positive and negative ends when they interact, or when this battery is in place, that stored chemical energy is then converted to electrical energy. That electrical energy goes to the light, giving off the radiant energy. I hope we talk about batteries in this class. They're pretty important. But yeah, let's double check. Yeah, that's correct. Yeah. Always double check. Select the correct answer. The energy entering the system is equal to the energy leaving the system. Based on the law of conservation of energy, how many units of energy are entering the system? Well, so this arrow is coming into the system, and these two arrows are leaving the system. So if you add what comes out, 10 plus 5, that much has to come in. So 15 units is going out. That means 15 units is also coming into the system. There is symmetry, balance to this energy. What does the law of conservation of energy state? B is the closest thing we got. It cannot be created nor destroyed. It merely changes forms. What is the name of Earth's innermost layer? Got the core. Ooh. Which sphere includes rocks and minerals? Well, we talked about that earlier. Geosphere. The atmosphere deals with air. Biosphere deals with living things. Hydrosphere deals with water. Geosphere deals with rocks and minerals. Eric throws a basketball straight up into the air. As it rises, which form of energy is increasing? Well, its position is changing. And based on that position, gravity will pull down on it more and more. And well, that is the answer. Elastic potential energy, that's not really an issue here. Electrical energy, no. Kinetic energy, it is moving, but when it's rising, it will eventually stop moving. So the kinetic energy will actually lower the higher it gets because it has to eventually come back down. It has to stop and change direction. And at the highest point, the gravitational potential energy will be high. And that's it. That's the end of that energy flow test. Not too bad. Not too bad. Hopefully, you guys understand most of the concepts by now. And yes, next time we're going to tackle thermodynamics. Sounds scary? Not that scary, honestly. But until next time, I will see you all later. Bye bye. Have a good week.